Good morning and happy Friday. Here's our first review packet for our inequalities test, which is Tuesday, November 21st. So I'm going to start right away just practicing some graphing on our number line. If you need to pause so that you can rewrite something or copy something over or just hear me say something again, go right ahead and pause and rewind as you need. So x is greater than 7. I'm going to plot my three integers on my number line, 7, and then the integer less than 7, and the integer greater than 7, 6 and 8. It's an open circle on 7 with an arrow to the right. Open circle because there is no equal sign. Arrow to the right, remember, we can make an arrow out of our inequality symbol, and it's going to go in the same direction as the arrow on our graph. And then graphing it helps us to write it in interval notation. With this example, we are starting at -7, but we can't equal 7. Not -7, +7, but we can't equal 7. I show that with the parentheses. And our arrow is pointing to positive infinity. So that means we end our interval notation with positive infinity. And as you know, infinity always gets a parentheses. Next, we have x is less than or equal to -4. Now, to show that x can equal -4, we put a closed circle on -4. And again, I want to remind you, you can make an arrow out of that inequality symbol, and that's going to tell you what direction to draw your arrow on your graph. Interval notation, our arrow is pointing to -infinity, so we start with the parentheses and -infinity. Our graph ends at -4 with a closed circle, so we end our interval notation with -4 and a bracket. It's really important that you remember that when you're graphing, you want to make sure that you have x on the left, unless it's an and compound inequality. But if it's just a simple inequality, you want x on the left. And the way you switch things is you just flip everything. You flip your x, and you flip your number, and then you flip your symbol. So this is x is greater than 9. This graph looks like this. And our interval notation is 9, infinity, parentheses with both. For number 4, we've got an and compound inequality. And like I told you, most of the time, these will be just represented with one graph on our number line because x is in between two values. So -2 is the low, or the lower bound, and we're going to put a closed circle because x could equal -2. And then our inequality ends at 3, our upper bound, with a closed circle as well. And x is all the values in between -2 and 3, including -2 and 3. We represent these with interval notation with just our start number, our low bound, -2, our stop number or our upper bound, +3, and then we determine parentheses or brackets based on our circles. Both numbers get brackets in this case. And then our last example is an OR problem. Quick little reminder that the U is OR and upside down U is AND. So x is less than 0. Just graph each of these. Pretend the other guy's not there. How would you graph x is less than 0? Open circle, arrow to the left. Okay, now pretend that other one isn't there and x is greater than or equal to 4 is your only one. Closed circle on 4, arrow pointing to all the numbers greater than 4. Two graphs, two interval notations. So we've got parentheses, -infinity, 0, parentheses, our OR symbol, don't forget that, and then bracket, 4, infinity, parentheses. All right, we're going to move on to naming certain integers in solution sets. I think it helps to draw a graph if you're unclear, but I'm going to go through this pretty quickly, so it might help if you stop and draw a graph and pause and think about it and then watch the rest of this video as I explain it. Anyways, we need to pick the smallest integer, in this case, that will work for x. Integers have no fraction or decimal parts, so for number 6, we're looking for the x value that's an integer that's bigger than 6. The smallest one. Lots of integers are bigger than 6. 8, 10, 2 million. What's the smallest integer that's bigger than 6? 7. It also helps to kind of throw that number there and then read that inequality and think to yourself, is that true? Is 7 greater than 6? If your answer is yes, then most likely you're right. For number 7, it's a little bit different. X can be equal to the negative 10. So it's going to be greater than or equal to negative 10. So the smallest number that's greater than or equal to negative 10 is actually negative 10. And I've said this a few times. Whenever it has the equal sign with it, greater than or equal or less than or equal, and I'm asking you for the smallest or largest integer. If the equal sign is part of the inequality, that number will always be your answer. Moving on to number 8, x is greater than or equal to negative 4. Very similar to our last example. 4 is the smallest number that's greater than or equal to 4. And for number 9, starring it again, once again, we need to have x on the left to properly read a simple inequality. So I put x on the left and my negative 2 on my right, and I flip my symbol. So x is greater than or equal to negative 2. What is the smallest integer that's greater than or equal to negative 2? And even though negative 1 is greater than negative 2, negative 2 is smaller than negative 1. So that's the smallest integer that works. And again, once again, like I told you, if it's got that equal sign, the number that they give you is going to be the smallest or largest integer. All right, let's get through 12 through 15. Very similar, but now we're coming from the other direction. We're looking for the largest integer that's less than or equal to a number. So what's the largest integer that's less than negative 1? I am going to draw a number line here. Negative 1, negative 2 to the left, 0 to the right. X is less than negative 1. Its graph looks like this. So I want the largest number, the one closest to negative 1. That's less than negative 1. It's got to be in the solution area. And so the largest integer that's less than negative 1 is negative 2. Remember to do 13, we need to flip everything. So we get x is less than 100. What's the largest number that's less than 100? The largest integer that's less than 100? 99. All right, now I'm throwing a decimal here at you. X is less than negative 12.5. Definitely graph this, especially if it's negative. Negative 13 is the integer less than negative 12.5. Negative 12 is the integer greater than negative 12.5. Our graph for x is less than negative 12.5 would look like this. This helps you to see that the largest integer that's less than negative 12.5 is negative 13. And then for number 15, x is less than or equal to 0. The largest number that's less than or equal to 0 is 0. Okay, so now we're moving on to compound inequalities and naming the integers in the solution set. And we're going to stick with and inequalities here because there's a start and there's a stop. Remember, integers have no decimal parts, so I set up our number line here. I think that's really helpful. You don't have to write all the numbers in, but if you do, then it'll show you what integers work for the inequality. And this is an and inequality, and this is the one time, or one of the times you will see x on the right when we combine it with another inequality involving x. So this 3 is less than or equal to x. You guys know that really means x is greater than or equal to 3 if I were to break it up and flip it. So I put a closed circle on my 3, and my x's, my solutions for x, are going to be all those numbers that are greater than or equal to 3. But wait, they also have to be less than 8. Not equal to 8 because there is no equal sign with that inequality symbol. So that's an open circle on 8, and our x values are going to be, our solutions are all of the x values that are in between 3 and 8, including 3, but not including 8. So let's go ahead and list the integers that would work here. Starting with 3, 3 will work for x. 4 will work for x. 5 will work for x. 6 will work for x, and 7 will work for x. We can't use 8 because x is less than 8, can't be equal to it. Okay, so now we're going to move on to number 17. Graph it, open circle on 8, open circle on 13. X is all the values in between 8 and 13, not including 8 and 13. So what integers would that be? 9, 10, 11, and 12. We don't include either the 8 or the 13 in our solutions here. Okay, so let's take a look at words and translating them into inequalities. Now, this is going to be really helpful for your test on Tuesday, and you probably want to replay this as a review on Monday night. So starting with number 18, x exceeds 70. Okay, exceeds means more than. So that would be x is greater than 70. Number 19. X has a maximum value of 10. That means the highest x could be is 10, the greatest x could be is 10, and x is going to be 10 or all the numbers less than it. X is less than or equal to 10. X is under 15 would just be x is less than 15. And here in 21, we have a compound inequality. X is at least -1. Now, we talked about this in class. At least is always greater than or equal to. So this is x is greater than or equal to -1. But also, which is the same as and, no more than 3. No more than means less than or equal to. So we take this inequality, and to write it as a single and inequality, we're going to flip our x is greater than or equal to -1 and write -1 is less than or equal to x. And now we just add on this x is less than or equal to 3. You can see that's what I have right there. You must be home by 12 o'clock, so appropriate times for you to get home would be x is less than or equal to 12 o'clock. And then numerical values for an A grade. An A is typically a 90 to a 100, so that would be 90 is less than or equal to x is less than or equal to 100. Okay, so we're going to go through, we're going to solve a few inequalities here. And again, I'm going to move quickly, and I have some of my answers mapped out for us already. So you might want to pause this if you need to take a minute to write it down, or if you want to replay something that I'm doing. We're starting off with simple inequalities. We're just solving them like they're equations. Using the same steps, we just need to look out for two scenarios. If we divide or multiply by a negative number, we flip our symbol. And if x ends up on the right, we flip our symbol. So let's go ahead and get started with 24. We're going to subtract 6 on both sides. That leaves us with 2x is less than or equal to 12. No, that's not true. 2x is less than or equal to 14. Now I divide by 2 on both sides, which gives me x is less than or equal to 7. The graph looks like this, closed circle pointing to the left, interval notation, parentheses, -infinity, comma 7, bracket. Number 25, we're going to subtract b on both sides. 10 minus 4b is greater than or equal to 74. Next, we subtract 10 on both sides to get -4b is greater than or equal to 64. Sorry, you can see my answer here. Sneaking up on us. All right, so I divide both sides now by -4, and flashlights and fireworks and things are going off in your head because you are dividing by a negative, which means you have to take this symbol and flip-a-roo. So our answer is b is less than or equal to -16. Graph, interval notation. Moving along. All right, distributing, you know how to distribute. 3x minus 6 is greater than 2x plus 14. Subtract your 2x on both sides. This one works out nice. x minus 6 is greater than 14. You could peek ahead of my answer that I wrote down ahead of time. When I add my 6 on both sides,